From theheart.org, Medscape Cardiology. This is the Bob Harrington Show. Dr. Robert Harrington is the Arthur L. Professor and Chair of Medicine at Stanford University. This podcast is intended for healthcare professionals only. Any views expressed are the presenter's own and do not necessarily reflect the views of WebMD or Medscape.
Hi, this is Bob Harrington on Medscape Cardiology and theheart.org. I'm here at the American College of Cardiology meetings in New Orleans. Having a great time, by the way. It's really fun to be back live in person, getting to see friends, colleagues, seeing live presentations, etc. If you've not been to a live meeting yet over the course of the last couple of years, please do start coming again, whether it's ACC, AHA, ESC, fantastic. All right, putting that aside, I've been learning a lot at this meeting, particularly around machine learning, artificial intelligence, and some of the advanced computational tools that people in the data science space are using. And I'm really fortunate to have an expert and really a rising thought leader in this field, Dr. Jenine John. Jenine is a machine learning research fellow at Brigham and Women's Hospital, working in Callum McRae's research group. And what she talked about on stage this morning is, what do you have to know about this whole field? And so what I thought we'd do is go through some of the basic concepts of data science. What is machine learning? What is artificial intelligence? What are neural networks? How do we start to think about this? Because as practitioners, we're going to be faced with, how do we incorporate some of this into our practice? You're all seeing machine learning algorithms put into your clinical operations. You're all starting to see ways that people are thinking about, for example, can the machine read the echo as good as we all can? What's appropriate for the machine? What's appropriate for us? What's the oversight of all of this? So we'll have a great conversation for the next 12 to 20 minutes and see what we can all learn together. So Jenine, thank you for joining us here today on theheart.org.
Thank you for having me.
Before we get into the specifics of what is machine learning, what do you need to know, give me a little bit of your story. So when did you become interested? So you obviously did internal medicine residency. You did a cardiology fellowship. Now you're doing an advanced research fellowship. When did you get bitten by the bug to want to do data science, machine learning, et cetera?
It was quite late, actually. So I, after a cardiology fellowship, I went to Brigham and Women's Hospital for a research fellowship. And I started off doing epidemiology research, and I took classes at the public health school.
Sort of classic clinical researcher.
Exactly.
Yeah.
So that was great because I gained a foundation in epidemiology and biostatistics, which I believe is essential for anyone doing clinical research. And basically, in 2019, I was preparing to write a K grant. And for my third aim, I felt, I want to make this complex model that uses a lot of variables. This thing called machine learning might be helpful. I basically just knew the term, didn't know much about it.
Yep.
But I just got this sense. So I talked to my program director, who led me to a group, Dr. Rahul Dayo and Dr. Callum McRae's group, that's doing healthcare AI. Initially, I thought I would just collaborate with them for the third aim of my K grant.
Have their expertise brought into your grant and sort of help to elevate the whole grant. And that's like also the typical thing to do.
Yeah,
right? Yep.
Exactly. But as I learned a bit more about machine learning, I realized, wait a second, this is a skill set I should really get into and try to develop. So I moved full-time into that group and learned how to code and create machine learning models, specifically for cardiac imaging. 6 months later, the pandemic hits. So everything took a shift again.
Yep.
And I believe it's a shift for the better because all of a sudden I was exposed to everything going on in digital health and healthcare startups. There was suddenly an interest in monitoring patients remotely and using tech more effectively. So I also became interested in how are we applying AI to healthcare and how can we make sure that we do this well.
So there's a couple things that I want to expand on. Maybe we'll start with this way. Let's do the definitions. How would you define artificial intelligence and its role in medicine, and then talk about a subset of that, define machine learning for the audience?
So artificial intelligence and machine learning, the two terms are used pretty much synonymously within healthcare, because when we talk about AI in healthcare, really we're talking about machine learning. And some people use the term AI differently. They feel that it's only if a system is autonomously thinking independently, that you can call it AI. But for the purposes of healthcare, we pretty much use them.
So we can use them for what we're going to talk about today. We'll use them interchangeably.
Yes, exactly.
Okay. Define machine learning.
So machine learning is when pretty much when a machine uses data and learns from that data. So it picks up patterns, and then it can basically produce output based on those patterns.
Give me an example that the audience that'll resonate with a clinical audience. You're an imager, and a lot of the work so far has been in imaging.
Yes,
yeah.
And imaging is really where machine learning shines. And for example, you can use machine learning on echocardiograms, and you can use it, for example, to pick up, does this patient have valvular disease or not? If you feed AI model enough enough echocardiograms, it'll start to pick up the patterns and be able to tell, does this person have valvular disease or not?
Yeah, and the group that you're working with has been very prominent in being able to say, do they have HCM? Do they have valve disease? Do they have amyloid infiltrative disease?
Exactly.
And because there's enough data there that the machine starts to recognize, and what the machine's doing is recognizing patterns.
Yeah.
And so you said something that you were at the Harvard School of Public Health doing what I'll call classical clinical research training. I had the same training. I was a fellow, 30 plus years ago in the Duke Data Bank for cardiovascular diseases. And it was about epi, biostats. How do you then apply those to the questions of clinical research? You were doing this very similar things. And you said something this morning in your presentation that stuck with me. You said you really need to understand these things before you make the leap into trying to understand machine learning. Expand on that a little bit.
Yeah, I think that's so important because right now what seems to happen is you have the people, the data scientists and clinicians, and they seem to be speaking different languages. So we really need more collaboration and more getting on each other's page. So when clinicians go into data science, I think the value is not in becoming pure data scientists and learning to create really great machine learning models. Rather, it's bringing that clinical thinking and that clinical research thinking specifically to data science. And that's where epidemiology and biostatistics come in, because you really need to understand those concepts so that you understand which questions you should be asking. Are you using the right data set to ask those questions? And are there biases that could be present?
Yeah, every week, as you know, we all pick up our journals, and there's a machine learning paper in one of the big journals all the time. And some of the pushback you'll hear, whether it's on social media or in letters to the editors, why did you have to use machine learning for this? Why couldn't you use, classical logistic regression? And one of the speakers in your session, I thought, did a nice job of that. He said, yeah, for a lot of times, standard conventional statistics are perfectly fine. But there are some times where the machine is just really better at doing things. And imaging is a great example. You want to talk to the audience a little bit about that?
Yeah, so I see it more as a continuum. And I think it's helpful to see it that way because right now we see it as traditional biostatistics and machine learning is something completely different, a completely different island. But really it's a spectrum of tools. And actually they're more simple machine learning methods that you can't really differentiate much from biostatistical methods.
Right.
So there's a gray zone in the middle. And for simpler data, such as tabular data, maybe...
Give the audience an example of tabular data.
So for example, if you have people who have gotten an MI, and then you have characteristics of those individuals like age, gender, and other factors, and you want to use those factors to predict who gets an MI. In that instance, for example, traditional regression may be the best. But when you get to more complex data, that's where machine learning really shines. And that's where it gets exciting because these are they're questions that we haven't been able to ask before with the methods that we have. And those are the questions that we want to start using machine learning to answer.
Yeah, one of the comments this morning, we've all seen papers, again, over the last few years. The Mayo Group has published a series of these about information that you can derive from the EKG. You can derive, for example, potassium levels from the EKG, not the extremes that we've all been taught, but sort of subtle perturbations. And I think I knew this, but I was still surprised to hear it when one of your co-speakers said, there's like 30,000 data points in the typical EKG.
Yeah.
There's no way you can use conventional statistics to understand that.
Exactly. And even humans, one thing I was a little surprised to see is that machine learning does quite well with estimating the age of the individual of an EKG.
Yeah.
And if you show a cardiologist an EKG, I mean, we could try get an approximate estimate, but we won't be as good as the machine. So modalities like EKG, like echo, that have so many more data points, that's where the machine can find patterns that even we can't figure out.
Yeah, and I mean, the secret is to ingest a huge amount of data, which is one of the things that people will ask me, well, why is this so hot now? Well, it's hot now for a couple of reasons, one of which is that there's an enormous amount of data available. Almost everything, every piece of information can be put into zeros and ones. And then there's cloud computing, which allows the machine to ingest just this enormous amounts of information. You're not going to tell the age of a person from from like a handful of EKGs. It's thousands to millions of EKGs the machine's evaluated to get the age. Is that a fair?
Exactly.
Yeah.
So this is where we talk about big data, because we need large amounts of data for the machine to learn how to interpret these patterns. And it's one of the reasons I'm excited about AI, because it's stimulating interest in multi-institution collaborations and sharing large data sets. Mm-hmm. So we're annotating and collecting and organizing these large multi-institution data sets that can be used for a variety of purposes. And we can use the full range of analytical approaches, machine learning or not, to learn more about patients and how to care for them. Yeah,
one of the things that I've heard both Callum and Rahul talk about this is they can get echoes, for example, from multiple institutions. And as the machine gets better and better at reading and interpreting the echoes or looking for patterns of valvular heart disease, et cetera, they can even take a more limited imaging data set and apply what they've learned from the larger expanded data set to basically to improve the reading of that echo. One of the things it's going to do, I think, is open up the opportunity for more people to contribute their data beyond just the traditional academics.
Exactly. And because so much data is needed for AI, there's a role for community centers mm-hmm. and other institutions to contribute data so that we can make robust models that work not just in a few academic centers, but for the majority of the country.
Now, I want to get into, there's two more topics I want to cover. One of which is, we've been in some ways talking about like the hope of what we're going to use this for to make clinical medicine better. There's also what's been called the hype and the pitfalls and the perils. And then I want to get into what do you need to know, particularly if you're a resident, fellow, junior faculty member. Let's do the perils and the hype. I hear from clinicians, particularly clinicians of my generation, we'll call it, well, this is just a black box. Like, how do I know it's right? And people point to, for example, the EPIC sepsis model, which failed miserably. The big headlines all over the place. And they worry, how do I know this is right?
And that's an extremely important question to ask. We're still in the early days of using AI and trying to figure out the pitfalls and how to avoid them. And I think it's important to ask along the way for each study, what is going on here? Is this a model that we can trust and rely on? Mm-hmm. I also think that it's not inevitable that AI will transform healthcare just yet, because we are so early on and there is hype. There are some studies that aren't done well. And what we need is more clinicians understanding machine learning, getting involved with these discussions so that we can sort of lead the field and actually use the AI to transform healthcare.
Do you think that as you push algorithms into the healthcare setting, do we need to, how do we evaluate them to make sure that the model's robust, that the data is representative, that the algorithm is giving us, I'll call it, the right answer?
Yeah, that's the tough part. And I think one of the tools that's important is a prospective trial. So not just creating an algorithm and implementing it right away, but rather studying how it does. Is it actually working prospectively before implementing it? And we also do need to understand that in healthcare, we can't necessarily accept the black box. We do need explainability and interpretability, really get an understanding of the variables mm-hmm. that are used and how they're being used within the algorithm and how they're being applied. So one example that I think is important is Optum created a machine learning model to predict who was at risk for medical complications mm-hmm. and high healthcare expenditures. And the model did well, So they use the model to determine who should get additional resources to prevent these complications. And it turns out that African Americans were utilizing healthcare less, so their healthcare expenditure was lower. And because of that, the algorithm was saying these are not individuals who need additional resources.
So it's classic confounding.
Exactly.
Yeah.
So there is algorithmic bias that can be an issue, and that's why we need to look at this as clinical researchers and say, what's going on here? Are there biases that are happening?
Yeah, one of the papers over the last couple of years actually came from one of our faculty members at Stanford, which looked at where is the data coming for these models, and pointed out that there's many states in this country that contribute no data to the AI models. That's part of what you're getting at. And that raises all sorts of equity questions, because guess what? Many of those, you're in Massachusetts, I'm California, a lot of data coming from those two states. Mississippi, Louisiana, where we are now, much less data.
Yeah, exactly.
How do we fix that?
And I think we fix it by getting more clinicians involved, because data scientists, I've met so many passionate data scientists who really want to contribute to patient care, make the world a better place, but they can't do it alone. They can't recruit health centers in Mississippi. We really need clinicians, clinical researchers who will say, I want to help with advancing healthcare, and I want to contribute data so that we can make this work. Because, currently we have so many advances in some ways, but AI can just open up so many new opportunities.
Yeah, and there's this whole movement to assure that the algorithm is fair, right? That's the acronym that's being used to make sure that the data are representative of the populations that you're interested in, that you've eliminated the biases. The other question on this, I'm always intrigued when you talk to your friends in the tech world. They say, well, we do this all the time. We do A/B testing. And they just constantly run through algorithms through A/B testing, which is a randomized study. How come we don't do more of that in healthcare?
I think it's complicated because we don't have the systems to do that effectively. So if we had a system where patients come into the emergency room and we're using AI in that manner, then maybe we could start to incorporate some of these techniques that the tech industry uses. But that's part of the issue. One is setting up systems to get the right data and enough data. And the other is, how do we operationalize this so that we can effectively use AI within our systems and test it within our systems?
Yeah, as a longtime clinical researcher, clinical trialist, I've always said, why is it that clinical research is like separate from the process of clinical care?
Exactly.
And if we're going to really effectively evaluate AI algorithms, for example, we've got to break down those barriers and bring research more into the care domain.
Yeah, I love the concept of a learning health system and really incorporating data and data collection into the clinical care of patients. And,
I fundamentally, I believe that clinicians make two types of decisions. One of which is that the answer is known. And I always use the example, aspirin, if you're having an ST segment elevation MI, that's known. That it shouldn't be on the physician to remember that. The system should enforce it. And the algorithms, et cetera, should enforce that. On the other hand, much of what we do, the answer is not known or it's uncertain.
Yeah.
And why don't we allow just ongoing randomization to help us decide what is appropriate? We're not quite there yet, but I hope before the end of my career that we can push that closer together. All right, final topic for you. You talked this morning about what do you need to know? Cardiology fellows, residents must approach you all the time and say, hey, I want to do what you do. Or, I don't want to do what you do because I don't want to learn the code, et cetera, but I want to know how to use it down the road. What do you tell students, residents, fellows, what they need to know?
So I think all trainees and all clinicians actually should understand the fundamentals of AI because it is being used more and more in healthcare, and we need to be able to understand how to interpret the data that's coming out of AI models. So I'd recommend looking up topics as you go along. And something I see is clinicians sometimes avoid papers that involve AI because they feel they don't understand it. But just dive in and start reading these papers because most likely you will understand most of it. And you can look up topics as you go along. And there's one course I recommend online. It's a free course through Coursera called AI in Healthcare Specialization. It's a course by Stanford, and it does a really good job of explaining concepts without getting into the details of the coding and the math. Other than that, for people who want to get into the coding, first of all, I'd say don't be afraid to jump in. I recently talked to a friend who's a gastroenterologist, and she said, I'd love to get into AI, but I don't think I'd be good at it. And I asked, well, why not? And she said, because men tend to be good at coding. And I do not think that's true.
I don't think that's true either.
It's interesting because we're all affected to some extent by the notions that society has instilled in us. So sometimes it takes some effort to go beyond what you think is the right path or what you think is the traditional way of doing things and say, what else is out there? What else can I learn? Yeah. If you do want to get into coding, I would say that it's extremely important to join a group that specializes in healthcare AI, because there are so many pitfalls that can happen. There are mistakes that could be made without you realizing it if you try to just learn things on your own without guidance. So
like anything else, join an experienced research group that's going to impart to you the skills that you need to have.
Exactly.
And I'm in, your question about, women maybe not being less capable coders than men. We both say we don't believe that. The data doesn't support that. It's interesting. At Stanford for many years, the most popular major for undergraduate men has been computer science. In the last few years, it's also become the most popular major for women undergrads at Stanford. Oh, wow. So we're starting to see, to your point, that maybe some of those attitudes are changing. Mm-hmm. And there'll be more role models like you to really help that next generation of fellows. Mm-hmm. Final question. What do you want to do when you're finished?
So my interests have changed a lot. Mm-hmm. And now I'm veering away from academia and more towards the operational side of things. Because as I get into it, my feeling is that currently the challenge is not so much creating the AI models, but rather, as I said, setting up these systems so that we can get the right data and implement these models effectively. So now I'm leaning more towards informatics and operations. But I think it's an evolving process. Medicine's changing quickly. Yep. And that's what I would say to trainees and other clinicians out there as well. Medicine's changing quickly, and I think there are lots of opportunities for clinicians who want to help make it happen in a responsible and impactful manner.
And get proper training to do it.
Yes.
Great. Jenine, thank you for joining us. And I want to thank you, the listeners, for joining us in this discussion about data science, artificial intelligence, machine learning. My guest today on Medscape Cardiology and the Heart.org has been Dr. Jenine John, who is a research fellow at Brigham and Women's Hospital, specifically in the data science machine learning realm. So again, thank you, and thank you for joining.